Okay, so I asked you to do the questions on page 478, starting with number 14. A 32-kilogram child is practicing climbing skills on a climbing wall while being belayed by a parent. So belayed just means they have a security rope attached to the kid that the parent's holding up top. That way if the kid slips, they don't just fall. And of course, the kid loses her grips and dangles from the end. So now there's a tension. The parents are holding the kid up, and they begin to lower the child, and when they do, the tension is 253 newtons, and it wants to know what is the acceleration. So you're going to do sum of the forces in the y direction, and if we call up positive, it'll be Ft minus Fg equals may, and you're solving for ay. So Ft minus mg over m. So 253 newtons minus 32 kilograms times 9.81 meters per second squared divided by 32 kilograms. And when you do this, you get a negative 1.90375 meters per second squared, and negative simply means the kid is accelerating downward. Because I called up positive, because I called Ft positive. Okay, number 15 says, a 92-kilogram mountain climber rappels down a rope applying friction with a figure eight. Now, a figure eight is like a carabiner thing that the rope goes through, and you squeeze the two sides when you want more friction, and you release them when you want less friction. Okay, the rope, which is damaged, can withstand, okay, so here's the mountain climber, here's the Fg, here's the Ft. Okay, and it says the mountain climber is 92 kilograms. The rope which is damaged can withstand a tension of only, so Ft of 675 newtons. And then it wants to know, first, can the climber limit his descent to a constant speed? So we need to find out what Fg is. So multiply 92 by 9.81, and you get 902.52 newtons. If you could limit it to constant speed, it would mean that the sum of the forces would be 0. Since the rope's going to break if you apply more force than 675 newtons, there is no way this mountain climber can go down at constant speed without snapping the rope. So that's the first part. This one would have to be able to withstand at least his weight, and it can't. So part B says, if not, to what value can he limit his downward acceleration? So do sum of the forces in the y. And if we call up positive, it'll be Ft minus Fg is equal to may. And again, we're solving for a. So Ft minus mg over m. So the biggest that Ft can be is 675 newtons before it breaks, minus the 902.52 newtons divided by the 92 kilograms. And when you do this, you get an AY to be negative 2.473 meters per second squared downward. Okay, better than gravity, but still quite an acceleration. Like if this guy started from rest and was going down a mountain that was just like 50 meters high, and that was his acceleration, we could find his final speed at the bottom. Right, so this would go to 0. So 2 times 50 is 100, and 100, 2.473 times 100, and then take the square root. It means at the bottom he would be going his speed, and the mountain of 50 meters is pretty wimpy, 15.7258 meters per second, which in kilometers per hour is 56 kilometers per hour on this wimpy mountain. So the moral of this story is, don't take a damaged rope mountain climbing. Get one that will actually hold you. Number 16. A 10-kilogram mass is hooked on a spring scale fastened to a hoist rope. Okay, so a spring scale, like the ones that we used for the forces labs last year, right? So here's the spring scale, and then there's something attached to it, and this something is 10-kilogram mass. So obviously Fg is going down. And that should be mg, which should be 98.1 newtons. And then it says, as the hoist starts moving the mass, the scale momentarily reads 87 newtons. Well, what the scale is going to read is going to be the tension, right? Whatever you pull down on, that's what the scale will read. So the first part of the question says, what's the direction of motion? Well, the downward force wins, so the direction of motion is going to be down. And then it says, find the acceleration. So sum of the forces is equal to MAY, and you can choose, you can either call direction of motion positive, or you can call up positive, because we're still only going in a straight line. So FT minus FG equals MAY. So again, AY is equal to FT minus FG over M. So 87 newtons minus 98.1 newtons divided by 10 kilograms should give you an AY of negative 1.11 meters per second squared, where this means down. Okay? And then the third part of the question says, what's the tension in the hoist rope? Well, you kind of needed to know that before you could do part B. So the tension is the 87 they gave you in the question. Number 17 says, pulling on the strap of a 15 kilogram backpack, so this is 15 kilograms, and you're pulling on a strap, so you're applying an FT. So a student accelerates it upward, so they're telling us the A this time is 1.3 meters per second squared up. And obviously this is going to be Fg going down. How hard did the student pull? You're solving for Ft. So sum of the forces is equal to Ma in the y direction. So Ft minus Fg equals May. So Ft equals May plus Mg. So equals M was 15 kilograms times 1.3 meters per second squared plus, oops, off the screen, 15 kilograms times 9.81 meters per second squared. And when you do this, you get an Ft of 166.65 newtons. All right, number 18. Now, number 18 is a little bit funky because of the wording. So it's an elevator, and it tells you that a 485 kilogram elevator is rated to hold 15 people, average mass 75. So 15 times 75 plus the 485 of the elevator itself. So the mass in the elevator is 1610, sorry. So this is 1610 kilograms. It's going to have an Fg going down, which will just be that times 9.81. The elevator cable can withstand a maximum tension of 3.74 times 10 to the 4th newtons, which is twice the maximum force that the load will create. In other words, the Ft, the cable can withstand twice what this weight will require, which is a good thing because not everybody counts as they get on an elevator to make sure that there are only 15 people, and not everybody's mass is 75 kilograms. So the elevator people are like, oh, we better not put this right on the nose. So this 3.74 times 10 to the 4th newtons will never be the force upward. If the maximum load will generate half of that, okay? So that's the tension. And the question wants to know the greatest acceleration. So we do sum of the forces is equal to MAY, and so it'll be Ft minus Fg equals MAY. So A will equal Ft minus Mg over M. So this half of this, which would be 1.87 times 10 to the 4th newtons minus 1610 kilograms times 9.81 meters per second squared divided by 1610 kilograms. And when you do this, you should get A to equal 1.8049 meters per second squared. Works out to be positive because it's going up. Okay? You can ask me about this one in person if this half the thing, the load, screws you up.